Hello student, today we are going to start a new topic of class 12th, that is alternating current. See, there are lots of things to study in the class 12th alternating current. We'll start with average value of the current. This is alternating current. See, we must consider two things while doing derivation in the alternating current. That is, everywhere will have like E will be equivalent to E naught sin omega t and current will be equivalent to I naught sin omega t. Means current and EMF both are following sine waves. See, first we will be calculating average value of current. What is this? See, we say that it is that value of current which sends out same amount of charge for given resistance which an alternating value of current will send out for a given resistance in same time. See, let us suppose this is a resistance and it is connected to AC, and we say that it is that value of current which sends out same amount of charge through given resistance which an alternating value of current will send out through given resistance in same time. See, we know that how charge is related to current. We know that I is what? It is equivalent to delta Q by delta T. So when we calculate the amount of charge, it will be equivalent to what? I delta T, and we have said that it is following sine waves. It is coming out to be what? Sin omega t delta T, and we will integrate it to half time interval. So this is coming out to be what? This is minus cos omega t upon omega for the half time interval. It is coming out to be like this is I naught, this is omega, this is cos omega t by 2 minus cos 0. Clear? So we know that this is omega t is 2 pi divided by 2 is pi, cos pi is what? Minus 1. So we have this is minus I naught upon omega, this is minus 1, this is what? 2 I naught by omega. And we have said in the definition that the alternating value of the current will send out the same value which mean value of the current will send out through given resistance in same time. So mean value is I am, how much charge it will send through? This is I am into T by 2. What we will do is that we will equate them out. This is I am T by 2. This is what? 2 I naught upon omega. This is I am. This is 4 I naught. This is omega t. We know that this can be written out as 2 pi, and calculating the values you can get 0.637 I naught. Similarly, suppose we go for like t by 2 to t, it will be coming out to be minus 0.637 I naught. And for the, suppose we calculate for the whole time period 0 to t, it will be 0. Similarly, we will go for average value of the EMF. What is that? Average value of EMF. See, we say that it is that value of EMF which would send out same amount of charge through given resistance which an alternating value of EMF would send out through given resistance in same time. See how much is the charge which has flown through it is. Let's suppose this is the resistance, and this EMF have sent out certain amount of charge. That is, we know that I is what? Delta Q by delta T. Delta Q is what? This is I into delta T, and we had to correlate it with EMF. So I can be written as E by R delta T, and we know that E can be written as E naught sin omega T delta T upon R for the time interval 0 to T by 2. While integrating it out, what we are getting, this is minus cos omega T upon omega, this is 0 to T by 2. See what we will get, this is E naught, this is omega R, this is cos omega T by 2 minus cos 0. See, it is coming out to be what? E naught omega R, this is again, it is minus 1, this is minus 1, this is what? 2 E naught upon omega R. This is omega T is what? 2 pi divided by 2 is pi, cos pi is minus 1. So we are getting this. And as it had said in the definition that whatever the average value of the current has sent out through given resistance, the mean value will also send out through given. Then see, second equation will be what? That mean value of the EMF has sent out how much charge? Delta Q is equal to I into delta T. This is I into T by 2. So we equate them out. What do we get? This is EM by R into T by 2. This is what? 2 E naught upon omega R. So R get cancelled out. EM is again 4 E naught upon omega T. It is again coming out to be 0.637 E naught. These are the average value of the current and average value of the EMF which has passed through given resistance in the same time. Again, suppose we go for for T by 2 to T, it is again going, we get the result as minus 0.637, and we suppose we calculate for whole time period, it will be again be 0. The next topic will be RMS value of the current. See, RMS value of current. What is RMS value? Means root mean square value. Root mean square value of the current. See, we calculate it out like, suppose we have a resistance over how much heat it has produced. We say that it is that value of current, it is that value of current which will produce same amount of heat when passed through given resistance which an alternating value of current would produce when passed through given resistance in same time. So how to calculate this out? See, we know that according to Joule's law, heat production is what? Delta is what? I square R into delta T. So what we'll do is that we know that I can be written as out as I naught sine omega T whole square R delta T. So what we get? This is I naught square into R. We'll have to calculate the sine square omega T delta T, and it is going for the whole time period 0 to T. So what we get the values? These are I square R, and when we calculate the sine square omega T can be written as 1 minus cos 2 omega T upon 2 delta T. So suppose we calculate this out, I square R upon 2, we integrate this part delta T, this is integration of cos 2 omega T delta T. See what we get? I naught square upon my 2, this is T, it goes from 0 to T, and integration of cos 2 omega T is what? Sin 2 omega T upon 2 omega, it goes from 0 to T. See, when we place the values over here, it is coming out to be what? I naught square R upon my 2, this is T, and what is this part? 4 omega, this is sine 2 omega T minus sine 0. Both are 0 because we know that at sine n pi all the values are 0, and this is sine 0. So it is not contributing anything. We are getting this result. This is equation 1, and we equate it by RMS value of the current written out as IV. So heat production will be IV square R into T. This is second equation. We equate this out. This is what? IV square R into T. This is what? I square R into T by 2. This get cancelled out. What we are left with? IV is equivalent to I naught by root 2, or we can write IV as 0.707 I naught. This is clear. Now we will move on to RMS value of the EMF. See, what is the RMS value of the, it is again RMS root mean square value of the EMF. See, again we will define it out as what? It is that value of the EMF which will produce same amount of heat as alternating value of EMF will produce when passed through given resistance for the same time. RMS value of the EMF, it is that value of EMF which would produce same amount of heat when passed through given resistance which an alternating value of current would produce when passed through given resistance for the same time. Given resistance for same time. As we have discussed in the definition, heat produced, so we will follow that. Joule's law. This is I square R into T, but we have to correlate it with EMF. So what we have to do is that E by R whole square R into delta T. This is what? E naught sine omega T whole square upon R delta T. See, it could be written as E naught square upon R. This is again integration of sine square omega T delta T. It goes from 0 to T whole time period. So what will we get the values? We have to integrate sine square omega T. See, we have to modify it because we do not have direct formula of sine square omega T. What we do is that we convert using trigonometric function 1 minus 2 omega T upon 2. This is delta T. So what it becomes? E naught upon 2R. First we integrate this delta T and then we integrate cos 2 omega T delta T. See, it will result to what? This is E naught square 2R. This is what? Integration of delta T is what? T. It goes from 0 to T. Again we have sine 2 omega T upon 2 omega. This is what? 0 to T. See, when we calculate this out, it is coming out to be what? 2R. This is what? T minus 0. Again this is E. This is 2R into 2 omega. And what we have? This is sine 2 omega T minus sine 0. Over here, this is also 0. This is also, so it does not contribute anything. The heat production is E naught 2R into T. Again, what we will do is that we will go for RMS value, that is EV. Heat production due to RMS value of the EMF is what? EV upon R whole square into R into T is equivalent to what? E naught square into 2R into T. So what we see that this T get cancelled out. We are getting EV square E naught square upon 2, which is coming out to be EV upon E naught by root 2, that is 0.707 E naught. Again, suppose we have like this is it is quite similar to that of the RMS value of the current. It had in current we had IV is equal to 0.707 I naught. Over here we have EV is equal to E naught by root 2 or 0.707 E naught. E naught is basically the maximum value of the current, maximum value of the EMF. And EV is what? RMS value. See, next topic will be that what is the phase relation between current and EMF in AC circuit containing resistance only. Suppose in a circuit we have, let us suppose we have like only resistance in the circuit. So what is the phase relation between E and I in an AC circuit containing resistance only? See, we know that E is what? E is E naught sine omega T. Let us suppose we divide it by resistance. So it is coming out to be what? E naught upon R sine omega T. So it is coming out to be what? I naught sine omega T. So we see that it has like quite similar. So suppose we draw the phasor diagram of it. It is coming out to be like this. The EMF, this is suppose I naught, this is E naught, and the phasor part, let us suppose this is I naught, this is E naught. We see that the phase difference between them is 0 because they attain same values, maxima at the same time and the minima at the same time. So there is no phase difference in an AC circuit containing resistance only in the between EMF and the current. Next, we'll move on to what is the phase relation between current and EMF in AC circuit containing inductor only. Means we have like phase relation between E and I in an AC circuit containing inductor only. See, in the last topic, inductor, we had done that. What was the relation between the EMF and the inductor? E was equivalent to minus delta phi by delta t. This is E is equal to delta I by delta t. This is the relation between EMF and the current. See what we have. This is utilizing this equation, E delta I by delta t. See, you could remember that E was equivalent to what? According to Faraday's law, it was delta phi by delta t. Flux was equivalent to what? L into I upon delta t. From here only we are getting this. And now we have to find the phase relation between them. What we'll do is that we'll integrate that out. E can be written as E naught sine omega t L integration delta t. While we integrate it out, it is coming out to be what? It is coming out to be minus cos omega t upon omega. So we know that, see, EMF is written in terms of like E naught sine omega t, and to compare the current with it, what we have to do? We have to convert this formula in form of E sine omega t. So what we have, this is E naught, this is omega L, this is cos omega t. See, cos omega t can be written as sine pi by 2 minus omega t, and this negative, what we can do is that we can multiply inside the angle. This is coming out to be what? Sine omega t minus pi by 2. And see, this is current, this is EMF, and this is basically resistance. And what is that? XL is basically inductive reactance. Resistance in the case of inductor is what? Inductive reactance. So it is coming out to be what? E naught upon XL. This is sine omega t minus pi by 2, which can be written as what? I naught sine omega t minus pi by 2. See, comparing it, what we are getting is that EMF leads and current lags behind EMF by pi by 2. See what we have. Suppose we see that this is like, suppose this is the EMF, then current is 90 degree behind. This is 90 degree current. This is EMF. In the case of inductor, we see that current lags behind EMF by pi by 2. This is a phasor diagram. This is the EMF, this is the current, and current lags behind EMF by pi by 2. Next, we will go for phase relation between E and I in AC circuit containing capacitor only. We will go for phase relation between E and I in an AC circuit containing capacitor only. See, we know that in the case of capacitor, what we have? I is what? Delta Q by delta T. And we know that Q is what? C into V in the case of capacitor. C into V, or we can write C into E. So I is basically what? C into V or C into E, which can be written out as E naught sine omega T derivative. You have to get the derivative of it. It is what? C into E naught basically. This is what? Derivative of sine omega T is what? Cos omega T into omega. So what we have, EMF is E naught sine omega t, and what we are getting current as, this is E naught, this is CE, C and omega we can write it out like this, and this is cos omega t. Again, in order to compare cos omega t and sin omega t, we already have, like, this is E naught sin omega t, we'll convert cos omega t in terms of sine. So what we are getting, this is E naught, this is XC, this is sine pi by 2 plus omega t. It can be written at out. Cos omega t can be written out like sine pi by 2 plus omega t. So what we have, this is I, this is I naught, this is sine pi by 2 plus omega t. See, what is this XC? XC is basically capacitive reactance. Basically, it is counterpart of resistance in the case of capacitor, and its value is what? 1 upon omega c. See, we see that in the case of capacitor, current leads EMF by pi by 2. When suppose we go for the phasor diagram, what we have, this is current is leading and EMF lags behind by 90 degree. This is EMF, this is means in a circuit containing capacitor only, current leads EMF by pi by 2. These were the very important topic related to the AC, and the rest of thing we'll discuss in the next class. What you have to do is that you have to go through, revise it out, and be thorough with these things so that you can master the second part of it in the next class. Thank you.